elements. So we have an element like this. This distance is r, that is theta. Somewhere over here for reference we have an x and a y. This displacement is u, that displacement is v. This distance, this angle is delta theta. Now epsilon r, let this be A, let this be B. Epsilon r has to do with the change in AB. So this is equal to A prime B prime minus AB by AB. And if you think of it, this AB, A, B, A may move in this direction a little and B may move in this direction a little, and that changes the angle a little, but it does not change the length to first order. And it moves in the radial direction by u, and this one moves in the radial direction by u plus del u del r times delta r. That length there is delta r, and so the change in length is del u by del r delta r. We divide that by the original length and we get del u by del r. This is the easiest. Okay, we've got epsilon r. Now we want to do epsilon theta. For epsilon theta, what we have to do is we have to see how this changes. So let this point be C. Now we want A prime C prime minus AC by AC. So here's the thing, because these are not really parallel, these two directions are not really parallel, that is why there is a consequence of u as well. Okay, so here there is u and v, here there is u and v. This is of course not u, so let me write it with red here. This is u and this is u plus del u del theta delta theta. Let me draw this with green. This is v and this is v plus del theta, del v del theta delta theta. So, and the length of the arc itself is r plus u delta theta. Okay, so new length A prime C prime is equal to r plus u delta theta plus del v del theta delta theta minus AC is minus r delta theta, and so we have epsilon theta is equal to u plus del v del theta by r is equal to u by r plus 1 by r del v del theta. This is the next easiest. Okay, so let me put a red or orange star here and another star here. These are numbers to check or expressions to check. The shear strain is gamma r theta. For this we should remember that in our x and y axis we were looking at this angle, and the sum of those two angles, with the original being 90 degrees. The direction corresponding to x for this element here, the direction corresponding to x is the r direction. That means we are looking here. Okay, we are looking at point A. Okay, now it is simpler if we think of gamma being linear in u and v and their derivatives. Okay, so due to u alone we can find whatever it is, due to v alone we can find whatever it is, and we can add them up. This makes it conceptually simpler. Okay, very good. The due to u alone part is easy because this one doesn't change. We are interested in this angle, so we are only interested now in the rotation of this part. Okay, so now this one moves in this direction, this point moves in this direction because we are doing u alone, and so this angle doesn't change. This angle does change because over here this one is u, and over here this one is u plus del u del theta delta theta, and therefore the angle that we get is the excess of that one over this one, and so from here we get del u del theta delta theta divided by this arc length, which is r delta theta, and so we have 1 by r del u del theta. Now let us do the part which is due to v alone. So when we are doing the part due to v alone, we are doing this part now. So once again let me draw this element for clarity. And let me indicate the displacements like this. This is v, okay, and this is v plus del v del theta delta theta, and this is del v del r delta r. So there is this angle which is del v del r delta r divided by that length, which is delta r. So that is del v del r. Okay. However, remember that because of this v, what happens is this entire element also has a rigid body rotation, right? The base element, this has a rotation, right? Because this reference line is no longer here. The reference line is now based at this point and it has rotated by some angle. So this reference line has rotated by this angle here, which is v by r. And so we are actually interested only in this portion. That is the deformation part. This is the rotation part. And so we have to subtract minus v by r. Okay, and when we add these together, then let me write it, gamma r theta is equal to del v by del r minus v by r plus 1 by r del u del theta. And this was part of a tutorial problem. The tutorial problem is here. So epsilon r is del u by del r. We see that here, and epsilon theta was 1 by r del v del theta plus u by r. Epsilon theta is 1 by r del v by del theta plus u by r. So we see that here. And this one has three parts, gamma r theta. So there is the del v by del r minus v by r, del v by del r minus v by r, which we see here, plus the 1 by r del u del theta, plus the 1 by r del u del theta that we see here.